This is concept development for Engage New York, Module 4, Lesson 7. Our objective in this lesson is to multiply any whole number by a fraction using a tape diagram. And if you remember, a tape diagram is just a model, right? Okay, so we used two different models. We had counters, where we did counters, and then we did arrays, right? Where we broke things up. We've used counters and arrays. So to find fractions of sets. So today we're going to use tape diagrams to help us solve. We must find 3/5 of 35. So what is 3/5 of 35? So what is the whole number? The whole number is 35, correct? And we're trying to find a portion of 35. What is 3/5 of 35? 3/5 of 35. So how I'm going to do this using a tape diagram. So here's my tape diagram. It doesn't have to be perfect. My question for you is, how many units should we cut the whole into? How many units should this be cut up into? It should be cut up into 5. How do you know? Well, the denominator tells us we want fifths. That is a unit being named by the fraction. We are being asked about fifths, so we know we need 5 equal parts. So 1, 2, 3, 4, 5. Now, we know 5 units are equal to 35. So if this was 0, all the way over here is 35. How do we find the value of 1 unit? So this is our question mark. How do we find the value of just 1 unit? Well, let's find out. So we have 35, and we've broken it up into 5 equal parts. So we know that 5 units is equal to 35. Now, I'm going to write this in the algebraic way. So I'm going to solve. I'm going to divide by 5 and divide by 5. Whatever you do on one side of the equal sign, you have to do the same exact thing on the other side of the equal sign. And by doing this, I cancel out those 5 and it becomes 1 unit, right? So 35 divide 5. I'm going to take 35 and divide it up into 5 equal parts. What does that equal? 7. So, have we answered our question? No, we haven't answered our question because technically we were trying to find out 3/5 of 25. But if we find out what 1 unit is equal to, then we can figure out the rest, right? So if 1 unit is equal to 7, then we know that all of the units are going to be equal to 7. And if we have 3 groups of 7, we're going to have what? Because we need 3/5, right? We need 1, 2, 3 of the 4, 5. So you could just simply 3 times 7 equals 21, or 3 times 7 equals 21, right? So 3/5 of 35 is equal to 21. All right. So our answer to the problem, what is 3/5 of 35? 3/5 of 35 is 21. So 3/5 of 35 is equal to 21. Now, problem 2. Ariella buys 2 dozen roses. Of these roses, 3/4 are red and the rest are white. How many white roses did she buy? What do you know about this problem? Well, I know the whole. What is the whole that we're trying to break up? Well, we're trying to break up 2 dozen, but how many are in 2 dozen? I know 1 dozen is equal to 12. So 2 dozen has to be equal to 24, right? So what is our whole that we're dividing up? That we're multiplying, we're going to multiply a whole number by a fraction. So our whole number is 24 and our fraction is 3/4, right? Well, of these roses, 3/4 are red and the rest are white. How many white roses did she buy? So am I looking for 3/4? No, I'm looking for 1/4, right? All right, so what is our whole? Our whole is 24. How many equal groups are we going to break this tape diagram up into? Well, our fraction names what we're looking for, the fraction. How many equal parts we're going to break this up into, right? So we have 4 equal parts. Now, so 4 units is equal to 24, right? Well, if I want to find out what 1 unit is, 1/4, 2/4, 3/4, 4/4, right? I'm going to divide what I do on one side, I have to do to the other. That gives me 1 unit. And 24 divided by 4 is 6, right? So now we know that in 1 unit, there are 6 roses. How many white roses did she buy? That's what we're looking for. So you could take 24 and subtract, right? So you could first find the total of the red roses and then subtract from 24 to get the white roses. Since I know 1/4 of the whole of the white roses, I can now find 1/4 of 24 to find the white roses. That's faster. So, Ariella bought 6 white roses. So that is the answer to the problem. All right, here we go. Problem 3. Rosie had 17 yards of fabric. She used 1/3 of it to make a quilt. How many yards of fabric did Rosie use for the quilt? Well, what part can you draw? Right, you can draw the tape diagram because we know that, right? And we know that the tape diagram is equal to 17 yards altogether. What else do we know? Well, she used 1/3 of it to make a quilt. So the 1/3 tells us how many equal pieces we have to have of break this tape diagram up into, right? Thirds. So 1/3, 2/3, 3/3 would give us a whole, right? So how many yards of fabric did Rosie use for the quilt? So she used 1/3 of it to make a quilt. How many yards of fabric did Rosie use for the quilt? So she only used this amount to make the quilt. The rest we don't know what she did with. So compare this to the problems that we've done so far. So the answer that we're looking for is not a whole number. The quotient is not a whole number. We are still looking for fractional parts, but the answer isn't a whole number. So we draw out the tape diagram, we label it 17 yards, break it into 1/3 for the quilt, and then now what do? Well, we have to find out what the value of just one unit is, right? So how do you want to solve this? Think about it for a second. I want you to try something. I want you to try something on your own for 1 second, and then I'll jump right back in. Okay, did you say, I'm going to go back to what we've done before. 3 units is equal to 17 yards, right? Now, I want to find out what 1 unit is. So now I'm going to divide by 3 on both sides so that cancels it out and gives me 1 unit, right? Well, that's not going to divide easily. So you have to go 3 divide 17. That's going to be 15. Subtract. So it's 5 2/3. 5 2/3 yards. 5 2/3 yards. So if this is 5 2/3, this is 5 2/3, this is 5 2/3, right? Now, what do you want to do to check our answer? Don't you think we should check it? So truly, the answer to our problem is, how many yards of fabric did Rosie use for the quilt? Rosie used 5 2/3 yards of fabric. That's really the answer. But you could check your work and go 5 2/3 times 3. That would be one way to do it. Now you have to change this into an improper fraction because you can't multiply a mixed number like that. So 3 times 5 is 15, 16, 17. 17 thirds times 3 over 1. Cancel it out. Takes you right back to 17. Now you could, well, we know that multiplication is repeated addition. So you could go 5 2/3 plus 5 2/3 plus 5 2/3. Now, if this is 2/3, this is a third, 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 right? So 5, 10, 15 plus 1 plus 1 will take you back to 17 as well. All right, just checking our work, just pulling things apart so you can see where everything comes from. All right, our next problem is, what is 2/3 of a number is 8? What is a number? So we don't know. We know the answer, but we don't know the number. We don't know the whole that we're working with. So how is this problem different from the one we just solved? In the first problem, we knew the total and wanted to find a part of it. In this one, we know how much 2/3 is, but not the whole. Last time they told us the whole and asked us about a part. This time they told us about a part and are asking us to find the whole. So how are we going to start this? What do you think? Well, do you want to start by just drawing a tape diagram? So we know what we don't know. This is the question mark. How much does this all equal? Now, 2/3. So the thirds is telling us how many equal parts this is, right? And we know that 2 of the thirds together is equal to 8. And what we also should know is we know that 2/3 is the same as 8. So that means we can label 2 of the units with a bracket right here and 8. What the whole bar is worth, that's where we have our question mark. So how can knowing what 2 units are worth help us find the whole? So how does knowing that these 2 units is equal to 8 help us find the whole number? Okay, so since we know that 2 units is equal to 8, we can divide to find that 1 unit is equal to 4. So remember, it has to be equal, right? Because these are equal parts. So if these two are equal, the only way to separate 8 into equal parts would be by 4, right? So just by doing that, we now know there's 4 inside each unit. Now we can find the whole. So 4 times 3 equals 12, or 4 plus 4 plus 4 equals 12, right? All right. So to check your answer, like 2/3 of 12. So we could check our answer. 2/3 of 12 equals 8, right? So we could say 3 units is equal to 8. No, 3 units of 12. Excuse me. How are we going to do that? We're going to divide, so that cancels it out and gives us 1 unit is equal to 4. So 1 unit is equal to 4. That's the way we can go back and check to make sure it makes sense. And that's just another way of solving, but you have to know this number here. All right. So moving on to our last problem in concept development, problem 5. Tiffany spent 4/7 of her money on a teddy bear. If the teddy bear cost $24, how much money did she spend? Okay, so which problem that we've worked on today is most similar to this one? So this one is just like problem 4. We have information about a part and we have to find the whole. So where should we start? Well, because part of our objective today is to use tape diagrams to help us solve and illustrate or model our thinking, we're using a tape diagram, right? So we know. What we don't know is how much money did she spend? Oh, no. How much money did she have at first? How much money did she have at first? Okay. So we know 4/7. Tiffany spent 4/7 of her money on a teddy bear. And if the teddy bear cost $24, so the sevenths tells us that this whole unit, this whole bar has to be cut up into how many parts? That's right, 7. So 1, 2, 3, 4, 5, 6 7. And we know that 4 sevenths equal $24. What we don't know, though, is how much money she actually started with, right? So how should we solve this? So we drew a bar for all of the money, and we showed what the teddy bear cost. It cost $24, and it's 4 sevenths of her total money. And we put a question mark over the whole bar here. So do we have enough information to find the value of 1 unit? Yes, we do. How much is 1 unit? So let's solve. Let's solve using that algebraic way. 4 units. Okay, 4 units here. 2, 3, 4 is equal to 24, right? 4 units is equal to 24. So if I divide by 4, that cancels. 1 unit is equal to 6. So if one of these is equal to 6, what do we know about fractions? They're all equal parts, right? So we know that they all have to be worth 6. Each unit has to be worth 6. So now, instead of 4 units, we need to find out how many are in 7 units. So 6 times 7 equals 42. Tiffany started with $42. That's the answer to the question. How much money did she start with have at first? All right, so that'll do it for concept development. Your job now is to go over here to lesson 7 and go to the problem set. So what you're going to do is you're going to solve using a tape diagram. 1/3 of 18. So you're going to draw out, they don't have to be big, and divide them. What is the fraction? How many equal parts are you going to divide that into? You can use my strategy if you want. Have just, 3 units is equal to 18. Divide, it makes it easy. Then we have 2/3 of a number is 10. It's just like that problem 4 and problem 5. So look back at problem 4 and problem 5 if you're having trouble. And then we have solve using tape diagrams. There are 48 students going on a field trip. 1/4 are girls. How many boys are going on the trip? This is just like the other problems over here. You're going to solve using the same manner. 3 angles are labeled below with arcs. The smallest angle is 3/8. Is 3/8 as large as the 160 angle. Find the value of A. So it's 3/8 of 160. Then Abby spent 5/8 of her money and saved the rest. So this is kind of the flip of that problem 5. She spent 5/8 of it and saved the rest. If she spent $45, how much money did she have at first? Just like problem 5. Mrs. Harrison used 16 ounces of dark chocolate while baking. She used 2/5 of the chocolate to make some frosting and the rest to make brownies. How much more chocolate did Mrs. Harrison use in the brownies than in the frosting? So it's comparing. It's a comparison problem. So how much more chocolate did she use? So this is going to be a 2-step problem. Mrs. Harrison used 16 ounces of dark chocolate while baking. She used 2/5 of the chocolate to make some frosting and used the rest to make brownies. How much more chocolate did she use? So you need to find out how much more chocolate did she use than the frosting. You have to be able to say, well, the brownies, she used this much chocolate for the brownies. She used this much chocolate for the frosting. And then tell me, Mrs. Harrison used either more chocolate in the brownies or more chocolate in the frosting. That's how you answer that. All right. Now, this problem might seem a little daunting at first. It might seem a little scary, but you're going to use exactly the same skills that you're using over here. So don't get sidetracked. So the smallest angle is 3/8 as large as 160 degrees angle. So 3/8, and how many eighths is it going to take to get to one whole? So I want you to practice. I want you to try it out. As soon as you have tried all these problems here, it shows that there are only 2 problems, but they're broken up into A, B, C, D. As soon as you're finished, I want you to come back and check the video to see how you did on solving these problems. So that will be under part 3 of the video. So fluency is part 1, concept development is part 2, and then problem set debrief is part 3. So come back and check your work. That way you know you understand and you're doing it correctly and you can find any of your mistakes. Okay, thank you.